and divide by 3 factorial, and then we bring in x to the power 3. So we are sure that here we'll get the required significant figures. If you simplify, we have 1 plus half x plus half negative half x squared. So this 2 that is down here, I've taken it inside. This is the half that you're seeing. Plus half minus 1 is negative half minus 2 is negative 3 over 2, and the 3 factorial down is the same as 1 over 6 x to the power 3. Then this 3 reduces here to 2. So I have 1 plus half x minus 1 over 8 x squared, and then we count 1 to negative, so it will be plus, and we have 1 over 16 x3. Okay, now we have found the expansion, the series. Now in our series, wherever there is x, substitute 0.08, meaning that on the left and on the right, substitute wherever there is x 0.08. So on the left we have 1 plus x, so we have 1 plus 0.08 to the power half. This is equal to 1 plus half 0.08 minus 1 over 8 0.08 squared plus 1 over 16 0.08 to the power 3. Then on the left we have 1.08 after adding, and the half is the same as the square root, so that we have 1 plus 0.04 minus 1 over 8 0.0064 plus 1 over 16 0.000. 8 to the power 3 is what? 152. Yes. 6 significant figure, 6 decimal places. Then the 1.08, we make it a fraction. It will be 108 over 100. That's how we make a decimal number a fraction. Where there's a point, you put a 1, and all the numbers after the point, you put zeros in the denominator. Then you remove the point, so that we get 1.04. When we add these two, minus, we divide here, so we get 0.00. That is 18.0, 18.0. Now 18.60, 1864, 8, plus, again, we'll have 0.1230, 1, 2, 3. Then 16 in 15, 0. Should I say 16 in 1, 0, then 16 in 15. again 0, so again 0, then 16 in 152. Oh, this is supposed to be 512 and not 152. Okay, so that when we say 16 in 0 here, 1, 2, 3, so have 1, 2, 3, then 15 in 5, 0. 16 in 51, it goes, so we can just say 5, 512 divided by 16. So we get 3, 2, like that. Then now we subtract.
Sir,
Yes.
sir, I've got a kindly explain how you got 0 point. I want to know how to go about the division, the one you applied here.
On this part,
Yes.
okay. So we have first, we have 3 zeros, 1, 2, 3. So you pick them, 1, 2, 3. The next will be 16 in 5. It does not go. So you put a 0 here because it goes 0 times. Then you extend now 16 in 51. So you notice that 16 in 51 can go. So you can as well decide to use 12 and divide this by 16. So you can reduce it. 2 in 5, it goes twice, remainder 1. 2 in 11, 5, remainder 1. 2 in 12, 6. But 2 in 16, 8. Again, you reduce. 2 in 25, it goes 12 times, remainder 1. And 2 in 16, it goes 8 times over 4. Then 2 in 12, 6. 2 in 8, 4 over 2. And 2 in 64, 82. That's how you get the 2 that comes there. So after getting that, then now you say, okay, I can now subtract 1.04 minus 0.0008. That is 0, 0 there. So you have 391. So you have 2930, 1 point. Then you add 0.0004 zeros, 32. So you get 2329301. So from there, you have you're now back on the left hand side. The square root of 108 over 100 is the same as the square root of 108 over the square root of 100. The square root of 108, you can write that number as 36 by 3, and 100, the square root is 10. So on the left, we have the square root of 36, we know it is 6, only 3 will remain inside, over 10 is equal to that number I found there, 1.039232. Approximately now, because you have stopped putting the dots. So we need to multiply throughout by 10 over 6 so that it can cancel on the left and will remain with root 3 alone there. And then we'll have, when you multiply by 10 on top, you get 10.39232. Then divide by 6. So how do you divide by 6? When you're dealing with this one, it's the same approach of dividing. 6 in 10, it goes once, remainder 4. So point. 6 in 43, it goes 6, it goes 7 times, remainder 1. And 6 in 19, it goes 3 times, remainder 1. 6 in 12, it goes twice. And you have found the 4 decimal places you've been asked. So you end there, approximately. That's the value.
So,
Yes.
how do you know, like, if you expand it to the third power, it will give you 3 decimal places? Like, how do you know the extent of expansion?
Approximately power 3 gives any normal asked decimal places or significant figures.
Okay, thank you.
Yes. So there are at least, sometimes even 2, but that one you are guessing. But 3 we are sure. It will give you an approximate that is required. So if you understand this, then you can just do another question that is almost like this. That is, use a suitable binomial expansion to find, so that is example 2. Use a suitable binomial expansion to find 1 over root 0.99. Correct to 5 decimal places. So again, you pick the number given, 1 over 0.99. This is the same as 0.99 to the power negative half. Negative because the power has been, we found root in the denominator. It was supposed to be 0.99 to the power half. Now because we have taken it to the numerator, it will become 0.99 to the power negative half. Now we want to find an expression that we can use to approximate this value. So the easiest one here would be something to do with 1 plus x or 1 minus x.
Wait, sir, I have a question.
Okay.
What did you say, what did you say is the reason of taking it from a fraction into this other expression?
Because in the fraction, if we leave it in the fraction, it will be 0.99 to the power half, meaning that we have to do our series in the denominator when we find an expression.
Okay, that makes sense. Thank you.
So now we need to use either 1 plus x or 1 minus x. Now let's choose. If we use 1 plus x, we must equate it to 0.99. What will be the value of x? Here we'll get 1 minus 0.99 to be equal to negative x. Or you say x is equal to 0.99 minus 1. It's the same thing. Then here we get what? We get x is equal to negative 0.01. You can choose to use this, or you pick 1 minus x is equal to 0.99, so that you get 1 minus 0.99 is equal to x, so that you have 0.01 is equal to x. Either way, you'll be dealing with a negative. So we'll pick 1. So we'll pick 1. So let's pick 1 minus x, 0.99, implying that x is equal to 0.01. Then we'll get this and have it expanded. Put it where there is 0.99 and then expand it. So we'll get 1 plus negative n negative x plus negative n minus 1.
Sir,
Yes.
can you start from the beginning? My phone went off.
What happened?
It was low, so I didn't charge my phone yesterday, and it was low, so it went off. It was 0%. In fact, it's 0% right now.
Okay. So what we are saying is we want to approximate this value. And how do we do that? We find, first we write our fraction into this form. Anything coming from the from the denominator comes with a negative power. And then you look for an expression that has an x, such that whatever you do to this will give you the thing inside the bracket, that. So I've picked 1 minus x to be equal to 0.99. And then solve for x, we get 0.01. Then we get our 1 minus x and expand it. So we take it where there's 0.99 and find its series. And we do that by just identifying our n, our a, and our b. And those are already identified. So because they're already identified, then we'll just say Here we bring negative x, we square, and then negative half minus 1, and negative half minus 2. Divide everything by 3 factorial, and then negative x to the power 3. We have that, which becomes 1 plus half x, and then plus, we have negative half, then we have negative 3 over 2. When you subtract negative half minus 1, then we have 1 over 2, then we have x squared, plus negative half, negative 3 over 2, negative 5 over 2, and then 1 over 6. When I take the 3 factorial inside the brackets, and then we'll have negative x to the power 3. So now we have these 3 reducing 6 to 2, and nothing is touching 5. So we now have 1 plus half x. Then we have 2 negatives here, so we'll make a positive 3 over 8 x squared. Then we have 1, 2, 3, 4 negatives. They'll make a positive 5 over 16 x to the power 3. The series ends there. Now, in our series, where there is x, on the left we substitute 0.01. Automatically we'll get 0.99 to the power negative half. So this one, you just substitute on the left for formality, and on the right to approximate now. So you have 0.01 plus 3 over 8, 0.01 squared, plus 5 over 16, 0.01 to the power 3. So approximately, this value is going to be 1 plus 0.0. That is when you divide 0 by 2. 1 by 2 is 0. Then you put a 0 on the 1 so that you get 5. Plus 0. When you expand this, it will give us 4 decimal places, 0, 0, 0. Now we're supposed to get a 1. Now that 1 multiplied by the 3 which is up here, we'll have a 3 over 8 plus 5. Again, even the 5 also, when you expand 0.01 to the power 3, you get 6 decimal places. 1, 2, 3, 4, 5, 6. When you multiply 1 by 5 over 16. So because I put the approximation, I can leave it there. Approximately, this is going to be 1.005. We are told we need 5 decimal places. So plus 8 into 0 here, we get 0, 0, 0, 0. 8 into 3, we have 0. You add a 0, 8 into 30. It goes in 24 3 times and leaves a remainder of 6. So 8 into 60. Again, it goes in 56 7 times and leaves a remainder of 4. And 8 into 40 goes 5 times. Plus, we won't even have to go to the other side because, so this time around, before we get to the third term, we are able to get our 5 decimal places. So approximately, this is 1 point, we now add 0, 0, 5, meaning we have 1, 2, 3, 4 the 0, and 5 the 3. If we round off, it will be 4. So we have 5 decimal places. So that is our approximation. And that's how we approximate. If you want, you can say therefore 1 over root 0.99 is approximately 1.00504. You are done. Is there any question? Hope I said that if those guys claim the hour, there will be no question. There will be no class. Now they did not claim the hour. They might clear
Sir,
tomorrow. Yes.
what if on the values of A and B, we on both A and B we have X. Like let's say 2x plus something to the power something, and then they tell you to, okay, is it possible?
It's not possible for you to be told to approximate in such a manner. So the only possible way is when they fix a 1 or a constant somewhere, like question 6, which comes in that form. But even if they will guide you, they'll first give you something like this. Even if they don't, you treat this as a single variable. Suppose you let it to be y, and then do the expansion. When you are done expanding, when you're done expanding with y, then you can substitute wherever there is y, you substitute your x plus x squared. If I tell you to approximate, let's say when x is equal to 0.1, you come here and substitute 0.1 plus 0.0001, and then have 0.101. Is it? Have 0.1001. Yes. You substitute that. And then this is now your y. So instead of taking in here the x and the y, you just take this in the y. And you're done. That's the only way you can ask such a thing where the x is not just alone. Otherwise, other things will be very reasonable. So we're just trying to approximate using the series, like this question, where you first find the series. After finding the series, which is here, by just using the expansion 1 plus x to the power n. In this case, our n is half. Then when you are done in the series, you go for where there is x and substitute 0.8, the mentioned number in the question. After you substitute that number, you substitute both on the left and right hand side. Do the addition on the right, you get a constant. And then on your left, write your number as a fraction. Then from there, use properties of SADS to extract what you're looking for. We're looking for root 3. So we break any number given there by 3. After the 100 has come out, 108 we divide it by 3, you get 36. 36 has the direct square root, so which is 6. So you take it out and remain with root 3. Then you multiply your 6 over 10, get the reciprocal, which is 10 over 6. Then remain with root 3 and have your approximation like that. The same setup for where you have to approximate a constant. So you just find an expression that will help you to have a series. And then in that expression, when you substitute some values of x that you find, you'll be able to get the asked value, which is approximating the given constant. Now I've run out of time, so we need to log out and log back for questions.